you guys a lot, but we are doing 6-3 today. And so this is C period, last day. I don't teach D&E until Monday, but I want them to also have access to it whenever they're ready. So 6-3 is a lot like 6-2. So in all of 6-2, we were saying if a quad is a p-gram, then a bunch of things, right? What's one thing that we knew? If a quad was a p-gram, what's one thing we knew? Billy, give me one.
Well, it has two sets of parallel.
Good. It has two sets of parallel sides. Good. If a quad is a p-gram, what's another thing we knew? Opposite angles are congruent. Very good, Kate. If a quad is a p-gram, what's another thing we knew, Caleb? Are supplementary. Consecutive interior angles are supplementary. Good. If a quad is a p-gram, what's the fourth thing we knew? Billy again? The diagonals bisect each other. And then there's one more thing. If a quad is a p-gram, then I don't remember this one. Billy, you think you know? I think that's one we've missed. Opposite sides are congruent. So all of these I started with if a quad is p-gram, then. If a quad is p-gram, then. Now we're switching it. So if we do the last one, Billy said, we're essentially saying if the opposite sides are congruent, then a quad is a p-gram. So that is our converse that we learned back in chapter 2. So today is basically, these are all the converse of 6.2 theorems. The only problem is we've got to be a little bit more specific and we need to find a little bit more information with some of these. So just be ready for that. So the first one, there's 6 of them, which is one more than what we learned the last time. So the first one is the by definition. So if a quadrilateral has 2 pairs of opposite sides, of course I sit down and I put my feet over here. I just want to be super particular, make sure I'm giving the same information to everybody. If a quad has 2 pairs of opposite sides parallel, so I'm going to write 2 pairs of opposite parallel sides, then it is a parallelogram by definition. So the first one that we've done before we did if a quad is p-gram, then 2 pairs of opposite sides. Now we're switching it. If 2 pairs of opposite sides are parallel, then it's a parallelogram. The next one are more ways to prove that a quadrilateral is a parallelogram. The first one's a definition. These are all theorems. So I've got a picture and then I've got the word definition. So the first one says, if we know that AB is congruent to CD and we know that BC is congruent to AD, then we have a parallelogram. So that's specific. In general words, that means if a quad has 2 pairs of opposite sides congruent, then a quad is, and remember this shape is in reference to being a p-gram or a parallelogram. If you don't like writing p-gram, you can write it all the way out. I can't just say opposite sides are congruent. I need both pairs of sides that are opposite each other to be congruent in order for that to be true. All right, number 3, this one says if measure of angle 1 plus measure of angle B equals 180, and measure of angle A plus measure of angle D equals 180, then we have a parallelogram. So I'm saying in reference from angle A, I need both D to be its supplement and B to be its supplement. So that means if a quad has an angle that is supplementary, that is sup to both, stop. Sorry, I'm yelling at the iPad, not you guys. Both consecutive angles, then a quad is a p-gram. Do you see how the first one was 2? This one is both. It's important that all of these things are true, not just one. All right, number 4. Now I'm talking about opposite angles. If A and C are congruent, and if B and D are congruent, then I've got a p-gram. So now it's both if both pairs of opposite angles are congruent, then a quad is a p-gram. Again, 2 pairs of opposite angles. And then there's one more that we've already talked about. I think Billy reminded us of this a minute ago. If AE is congruent to CE, and if BE is congruent to DE, then we have a parallelogram. So in words, I'd say if the diagonals if a quad has diagonals that bisect each other. I'm also going to word it another way. So write bisect each other on the first line. And then the second line, I'm going to write or. The other thing we could say is that they share a midpoint. We mentioned that before, but sometimes like when we're looking at it the first way, I thought it was easier to think about diagonals being bisecting, but now it might be easier to think, oh, that they share a midpoint. And when we get into like the math we're going to have to do, it's going to make sense. Everybody with me? Jackson, you with me? Okay, just making sure. Don't want anyone to stay behind at the train station. All right. The last one is one that we haven't talked about before, though. This is a new rule now that we can know things to prove that it's a parallelogram. This is saying if BC is congruent to AD and if BC is parallel to AD, then it's a parallelogram. So that means if I have one pair, not both pairs, one pair of opposite sides that are both congruent and parallel, then the quad is a p-gram. And the quad is a p-gram. It cannot be one side is congruent and one side is parallel. One side is both congruent and parallel. Okay, I know that was a little dull, but does anyone have any questions on that? We need to go over that in order to know what we're solving for as we move into the future. Okay? Questions, thoughts, comments? All right, let's move to the next side. All right, this table right here is, I stole from the textbook, and these are ways that we're going to prove that a quadrilateral is a parallelogram. Today, we're not necessarily doing the math, but do you look at the third page and you see how much space I've given you, and I've given you coordinate points and a vertices? We're going to actually do math for every single thing to prove that these are true statements. So what we're going to do here is just talk about what that's going to look like and what work we would have to do. So the first method that I could use to prove that we've got a parallelogram is prove that both pairs of opposite sides are parallel. How do I prove that lines are parallel? What like math or formula am I doing? Caleb? It could deal with the angles, but it's going to be easier to do a different way. So that could work, but if I'm giving you coordinate points, how do I know what the slope is? Oh, I just ruined it. Oh, I hate that. I hate it. I'm trying to lead you guys up and I just went right over the cliff. We have to know slope, right? If I know that the lines are parallel, why is slope important? What do we know about parallel lines as slope? They have to have the same slope. So that's why it's important that we find slope. Now, if I want to find that both pairs of opposite sides are parallel, I have to do the slope 4 times. I have to do the slope of this line and this line, so that's 2 slopes. And then I have to do the slope of this line and this line, that's 3, 4. So I have to do 4 slopes. That's actually not too bad compared to some of the other things that we're going to do. Slope's not that hard. The second one says, prove that both pairs of opposite sides are congruent. What math do I need to do to show that something's congruent? You want to know what form? Caleb? That would, yep, if we knew their measures, that would be easy. What if I don't know and I just know like one's at 0.12 and one's at point like 510? How would I know their distance? I messed it up again, didn't I? Whew, I can't do this at the end of the day. I know that their measures, I know what their measures are if I do their distance. So if I'm like, okay, one point is here and then one point is here, and this is at 0, 4, and this is at 12, -1. I know that doesn't make sense. We'll make that 12, 7. We would find the distance between them to know what the length is. So think about the sides being congruent is like length. And that's distance. And this one you'd also have to do 4 times. Now, personally, I'd rather do slope 4 times than distance 4 times. I think slope is easier, but that is an option that we can do. The next 2, I'm not going to number. I'm just going to put little stars next to them because they are having to deal with the angles are given to me. So Caleb, you mentioned angles a minute ago. That's awesome if they're given to me, but if I don't know what any of the angles are, that's not helpful to me. Like if I'm not given an expression or a degree, I don't know what it is. But methods I could use is I could prove that the angles are supplementary to both consecutive angles. And I could also prove that both pairs of opposite angles are congruent if I was given like what their actual measures were. So I have no like formula for that. The next one we're going to see is prove that the diagonals bisect each other. How can I prove that diagonals bisect each other? Yeah. Midpoint, very good. The midpoint, we just said that they share a midpoint, and the whole reason I brought that back up again is because the midpoint formula is not a hard one to find, and if they share one, midpoint of this line should be the exact same as midpoint of this line. Very good. And this one is actually an easy one to do too, because you only have to do 2 midpoints. You don't have to do 4. There's only 2 diagonals, so do it twice, see if it's the same. And then the last one says, prove that one pair of opposite sides is congruent and parallel. How do I prove that they're congruent? What did we just say a minute ago? How do I prove that they're congruent? Would you say, Donna? Distance. And then how do we prove that they're parallel? By slope. Now this one you would have to do distance and slope both twice. This might not mean a lot to us today because I'm not going to make us do slopes or do distances, but when I see you on Tuesday, I am going to make us do that. And so it's important to think about, okay, you can't just do one slope and be done. You have to do all 4 slopes, or in this case, you have to do 2 slopes and 2 distances. And if you don't do all of that, you can't prove to me that it's true. All right, questions, comments, concerns, thoughts, suggestions? Nope, none. All right, let's keep going. I want to do the last 2 examples on this page, and if we get done, then we can work on homework. Does that sound like a plan? Yeah. Okay. These, we're using our knowledge that we just found out. Again, we're not really solving anything. We're using these theorems that we learned on the front page to decide if I can prove that this shape is a quadrilateral. Not that it's a quadrilateral, but specifically a parallelogram. What are some other quadrilaterals that I could have if it wasn't a parallelogram? Remember some specific shapes it could be instead? I'm just going to make a list. Like what's another 4-sided shape that's not a parallelogram? Drew? A trapezoid? A trapezoid. Caleb, what's another one? Did you think of another one that is a parallelogram? Okay. You can also name another 4-sided shape that is a parallelogram. A square. A square is another good example. A parallelogram is a big over, like umbrella over a couple ones. Square is another thing in that category. What's another like specific kind of parallelogram? A rectangle. Very good. And then I think there's one more. Drew. A rhombus. Exactly. And we'll learn specifically what those are. Those 3 are special types of parallelograms, but they've got special important qualities. But a trapezoid is not a parallelogram. And then what's one other shape? Does anyone know the other shape that's a 4-sided figure that's not a trapezoid or a parallelogram? Kind of a funny one. It's called a kite. Did you guys ever learn that in like middle school geometry? Kite. A kite, we usually draw like sideways like this. And we always draw its diagonals on it, and it has special properties too. So the whole point of what I'm listing right here is that these all have their own special properties, and the 6 that we just talked about are special and unique just to parallelograms. So we have to distinguish, is this a parallelogram or could this be another 4-sided shape? And all of these are 4 separate problems. So we're going to do A, and then we're going to forget about A and look at B. And then we're going to forget about B, and then we're going to look at C. So given each of these conditions, is ABCD a parallelogram? So if I'm given angle A is congruent to angle C, and angle B is congruent to angle D, is this a parallelogram? I want you to give me a thumbs up if it's yes, a thumbs down if it's no. Angle A and C are congruent, and angle B and D are congruent. That is the only information I have. Yes or no? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 yeses. 13. Yep, I missed a couple. Very good. Why is it yes? Who can tell me? Nolan. Oh, okay. Sorry. It looked like a hand raise. Let's do Gavin. Can you tell me why this one's yes? Very good. And if we go to the front side, it tells us specifically we have to have 2 pairs of opposite angles that are congruent. So I'm going to write that here. I'm going to say yes. And I'm going to say if 2 pairs of opposite angles congruent, then quad is a p-gram. All right, so now I'm going to forget letter A existed and we're going to look at letter B independently. Letter B says angle A is supplementary to B and D. So angle A is supplementary to both B and D. If you're not sure, let's put some number values with A, B, and D, right? Let's say angle A is like, I don't know, 50 degrees. What would that make angle D? And what would that make angle B? 130 as well. That's an obnoxious sound. Is that enough information to tell me if this is a parallelogram, yes or no? Where are we at? 1 person, 2 people, 3 people, 4 people, 5 people, 6 people, 7 people. Kamara, tell me what? What'd you do? Yes or no? Perfect. And why? Basically, both of its neighbors, both of its consecutive angles. And which number was that on the front side? Number 3. So Kamara's looking at the third one that we looked at today, and so that's why she said yes. So essentially, we have I'm going to say if quad has one angle sup to both consecutive angles, then quad is a p-gram. So I really do want us to be this specific. I want you to abbreviate as much as you want, but I need to see one angle sup both consecutive angles. Like those are keywords I'm looking for in all of this. And I'm gonna say then quad is p-gram. Everyone okay with that? Okay. Let's pretend letter B didn't exist. Let's look at letter C. Angle A and B are supplementary. Angle C and D are supplementary. Think about that. So angle A and B are supplementary. So I'm going to pretend those are 130 and 50. And then it said semicolon, C and D are supplementary. Caleb, what are you thinking? No. I agree with you. Why do you think no? Good. Judy, do you want to add to that? No? Perfect. We know how A and B relate to each other, but all it tells me is that C and D are supplementary. So for all I know, C and D are 110 and 70. Those are supplementary, and they're not congruent to the other ones, and that's 130 and 70 are not supplementary. So I have to know something. I either have to know like how B and C as well as A and B are related, or how A and D as well as A and B are related. I can't do them like separately and expect that to work. So we're going to say no on that. And I'm going to say why. The reason why, no. It didn't specify. It's not necessarily sup to both of its consecutive angles. We know it's sup to one of them. We know A and B are sup, and we know C and D are sup. So we know they're supplementary to one of their consecutive angles. We don't know how the other ones relate. And we can't just assume best interest. What is it in law? They say innocent until proven guilty. We can't do that here with quadrilaterals. We can't assume that it's innocent and that the angles are what we want them to be. No, we have to assume that it's not. until they tell us that it is. All right, last one of this example. AB is parallel to CD and BC is congruent to AB. So AB is parallel to CD and BC is congruent to AD. What do we think? Yes, no, yes, no. Why do you keep doing that, bud? 1, 2, 3, 4, 5, 6, 7. I see a lot of yeses, but I'm going to argue it's a no. Can someone tell me why I'm going to argue it's no? Donna, you know? So what does the theorem on the front say? Very good. So Donna said on the front, our theorem says that one pair of sides has to be both congruent and parallel. But on the back right here, we have one side is parallel and the other side is congruent. That is not good enough. It needs to be the same. So I'm going to say no. And I'm going to say has to be same side that's congruent and parallel. Has to be the same side. Does that make sense? That one was a new one and a weird one. Now that we've seen that, I want to trick you here. I don't want to trick you on the quiz. I want to, so already have learned that, already have seen that mistake. All right, I've got one more problem, and this is a proof. So let's set this proof out. I'm going to write statements and reasons. Now, if I give you a proof on a test, I won't make you write it out in like this big blank space. I'll give you a table. I don't know if I was just too lazy or what, but statements, reasons. You guys barely remember proofs, right? You got some knowledge of proofs. Do you remember how every proof starts? Given. Yep, just that basic, given, yeah. So let's shake those cobwebs off of our proof brain. So the statement, I'm going to write what's given. I'm going to write for my reason. I'm going to physically write given. So what was given to me is that angle ALN is congruent to angle DNL. And also ANL is congruent to angle DLN. And my reason for that, Nolan told me, is given. And that's how we start every single proof. Questions, thoughts, comments so far? All right. At this point, there's not a lot of else to work off of. So I'm going to go to the picture and be, all right, picture, I hope you can help me out. I hope you can tell me what else I know that I can write down. So I'm going to zoom into this picture and I see that I have ALN is congruent to DNL. Do you know why those angles are congruent? Or sorry, let me rephrase that. If those angles are congruent, do you know what else we know? Billy, what do you know? We do have reflexive. That's not going to help us here, but reflexive is definitely there. Drew? That would also be true, but that's not going to help us here. Caleb? Oh, those whole angles would be congruent. Yes, again, that's there, but that's not what I want to use. Let's think about it this way. What if I extended some lines? You guys all came up with really good points, but this is how I want to prove it a different way. If I drew these lines, and I drew a transversal in here. And what are these angles, Donna? What kind of angles are those? What's the word we use when we have parallel lines? Not here today. That's okay. Caleb? A and D would be congruent, but that's not what I want to use. I want to use these angles. I want to use these angles in the lines I just drew. Cooper, do you know what those angles are called? They're not exterior. Are they what? They're not consecutive because they're not on the same side. You've hit almost all of them, Kate. Opposite interior or alternate interior. Very good. And what happens if alternate interior angles are congruent? Then what do we know? Lines are parallel. I want to use this to tell me that these lines are parallel. So these are alternate interior angles. And if alternate interior angles are congruent, then lines are parallel. We've been spending a lot of time saying if lines are parallel, then alternate interior angles are congruent. We're doing a whole day of converses, I guess, because we're doing the converse of that. If alternate interior angles are congruent, then lines are parallel. And that's what I'm going to write here. So that means that LA is parallel to ND. And I'm going to write if alternate interior angles congruent, then lines parallel. Going off of that, does someone kind of see where I want to go next? I just proved LA and ND are parallel. Does anyone read my mind, know where I want to go next? Kate? LD and AN are parallel. And why is that true? The exact same reason, right? This time, though, we have to look at a different set of lines. So Kate picked AN and LD, A, because you knew we wanted parallel lines, right, Kate? You knew we wanted two pairs of parallel lines. So she's like, okay, I need to get this parallel. If I flip and look at instead of the left and right ones with the transversal, if I look at the top and bottom ones with the transversal, now I have these angles are congruent. And if alternate interior angles are congruent, then lines are parallel. So I'm going to write AN and LD. AN is parallel to LD. And that's the same reason as I just wrote above. So if you wanted to, you could keep that in step 2, or you can write a whole new step. It does not matter to me. And then now, why did I want to get these lines parallel? To prove that land is a parallelogram. And I'm done now, right? I've got my two pairs of parallel lines. I can say ALND is a parallelogram, but which of the 6 theorems on the front is the reason I get to prove this? I want to see on your fingers, which of the theorems on the front is the reason I get to prove this? 1, 2, 3, 4, 5, 6. Show me with your fingers. Drew's got it. Who else has got it? Caleb's got it. Show me with your fingers. You see a bunch of hands. JJ, which one do you think? Good. Which is which number? Number 1. I want it to be number 1 because I found 2 pairs of parallel lines. These guys are parallel and these guys are parallel. So JJ knew that we had to do 2 sets of parallel lines. And so I'm going to say if quad has 2 pairs, this is the long one, of opposite parallel sides, then quad is p-gram. Oops, out of room. That's kind of jank, but let it be. All right, we did it. Now, I do love the brainstorming you guys thought beforehand. This was just how I knew that I wanted to prove this proof. But technically, when like Caleb, you said you wanted L and A or D and A to be congruent. I don't remember who said that they wanted all of L and all of N to be congruent. We could have proved it that way. There were a couple ways that we could have proved it. I could not do congruent sides because I don't have enough information. and I didn't have a second diagonal, but we also could have looked at those angles and that might have been helpful too. So I love your brainstorming, but I think this is the most obvious. So that's why I picked this one. We're going to be done for today. This second page that we didn't get to at all, we're going to do on Tuesday when I see you again. And we're going to do homework now. So I gave you like 9 minutes for you to work on homework. It looks like this, and it's in your folder, and I have printouts if anybody wants a paper copy. It's just a two-sider, and there's a little bit of math, but mostly it's the theorem. So make sure that you're writing them exactly like we have them on our notes, and make sure that you are reading the directions to make sure you know what you're answering. That's all I got for today. Any questions? All right, this one's due on Tuesday. I might have already put an assignment up. I think I'm trying to be on top of it. For those of you watching on YouTube, I hope this was helpful. And I'm going to turn it off now.